So we need to, for integer programming, do just like we did for linear programming, which is we need to formulate the problem and then try to solve it. So if we can't formulate the problem, then there's no way we can solve it. So again, here is the general approach I think you should take to formulating problems. Read the problem once to get a general idea. Then read it a second time, trying to identify the big parts that are necessary. The decision variables, those are the mathematical symbols representing levels of activity, the quantities to be determined. What's the objective function? Right? It's the quantity that we're optimizing. Is it a maximization problem? Is it a minimization problem? Are we maximizing profit? Are we maximizing revenue? Are we minimizing cost? Are we minimizing time? And then constraints. Those are the binding relationships, the restrictions on us, right? And then attach a word description to each. Then our data elements, that's the input to the model, the coefficients. Remember, because in integer and linear programming, a number is a number. They are not random variables. All right? And then again, for our normal outline, you should say let, define a decision variable, be very specific of what they are, max or minimize the objective function subject to the constraints, and attach a word description to each. All right, so let's look at an example. Your friend, a real estate investor, wants your help in deciding how to invest her $2 million in new rental properties. So she has $2 million burning a hole in her pocket. She wants you to help her. The options are either townhouses or apartment buildings. Nothing else, just those two things. Townhouses cost $282,000 each, and there are 5 available. Apartment buildings cost $400,000 each, and there are an unlimited supply of these. So there's enough of them that even if she wanted to, that means there's at least 5, right? 400,000 into 2 million. So there's enough that if she wanted to buy that many, she could. All right. The property manager, which has to be hired, can devote up to 140 hours per month on these new properties. Each townhouse is expected to require 4 hours per month. Each apartment building is expected to require 40 hours per month. After deducting mortgage payments and operating expenses, annual cash flow is estimated to be $10,000 per townhouse and $15,000 per apartment building. We would like to maximize annual cash flow. So I've just told you what the objective function should be. Maximize annual cash flow. Right? So then you should go back, read it again, right? What things are there? What are we trying to decide? So we're trying to decide how many townhouses. That would be one decision variable. How many apartment buildings? A second decision variable. So just 2 decision variables. What kind of restrictions do we have? We already know what the objective function is. It's to maximize the annual cash flow. We have restrictions on budget. She has only $2 million to invest, and we know how much each cost. And there's also this hours the property manager has, right? So we need to make sure we stay under labor hours. So I've left this nice blank slide for you to go ahead and fill out for yourself. There is one other restriction. There are only 5 available townhouses, so we have to make sure we do not buy more than 5 because there are only 5. Right? So that's a third constraint that we need to make sure we add in. All right, so we'll formulate it next.